Today is the 10th of October 2024, and this will be our third video on completing the squares. Okay, today we are adding the manipulations because at times you have to use completing the squares, but it doesn't come out as two perfect squares like s plus 3 all squared minus 9 or minus 16 or minus 4. Okay, at times it comes out as x plus 3 all squared minus 11. 11 is not a squared, okay, but we need to use completing the square to arrive at the answer. Okay, so at times you need that method to help you substitute, and then you can go on further deducing whatever you want to deduce. So this is where, because if it gets x plus 3 all squared, the foundation student can do it. Okay, a good year 7, year 8 student in top set can do it. But here you need this knowledge, like when I taught you difference of two squares, you need this knowledge so that you can interchange where appropriate, so that you can continue with deducing whatever you want to do. Because when you go higher in maths, you realize that at times you might have to start manipulating, deducing stuff, and the faster you can see these things, the better it is to arrive at what you are supposed to prove. Okay, so when you look at abstract algebra and those things, if you end up doing those courses, you realize that you need to have these things on your fingertips. But the more you do it, and the more you solve questions like that, the easier it becomes, and then you start seeing the patterns. I'm trying to show you these patterns. Okay, watch last video for recap. Okay, I could just have done one video showing you how to do it, but I'm trying to bring in different examples. They look similar, but I'm trying to show you that it's not just expanding and subtracting. At times you have to go further and manipulate a bit, okay, to get what you want, and then you substitute in the equation, okay, of what you want. So that is why it's in the category of higher maths. Here, I started today's probability. A number is chosen at random from 1 to 50. Okay, find the probability of selecting numbers greater or equal to 15 and less or equal to 20. Okay, a few I think 2 videos ago we guessed it greater than 15, less than 24, so we didn't have to include 15 and 24, but this time around is greater or equal to 15. Okay, so we have to include 15, and less or equal to 24. So 24 is included. Okay, you know, I've been cautioning you about probability about the wedding. Okay, now probability of 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, 24, 24 and 15 are included here. The one we did before, 15 and 24, wasn't included. Okay, you can have a look at it. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 out of 50, which is equal to 1 out of 5. Okay, unlike the other one where we got 8 out of 50, which is the probability was 4 out of 25. Today we are doing more completing the squares, and then we'll do some manipulations. Okay, now let's consider x minus 6 all squared. Is x minus 6, x minus 6. If you expand, multiply x by everything in the bracket and minus 6 by everything in the bracket. Remember your signs. Your signs, that means the minuses. You end up getting x squared minus 6x minus 6x plus 36. So you now have x squared minus 12 plus 36 will be equal to x minus 6 all squared, which we have here. Okay, which we have here now. Now, to complete the squares, I need to get rid of this 36. So, to make this side 0, I subtract 36 from both sides. So, x minus 6 all squared minus 36 will give me x squared minus 12x. Okay. What are we separating? I was showing you. Now, this 6 here, okay, if you minus this here, if you double it, it will become minus 12. So, you can say that x minus 6 all squared, okay, 6 squared minus 36, okay, because it's in the minus 36, because in the end you are going to get plus 36 here. So if you subtract minus 36, then you can write all this as x minus 6, x squared minus this 6 times 2, which is 12x. So even looking at this, because it's a perfect square, if it's 37 or 25 and you have x minus 6, I couldn't write that. Okay, but because it's 2 squares, this 6 here is very important, because this 6 squared here is the 36 I have here. So I can have here a half of 6, okay, this half of 6 here, no, if I double 6 is 12, so I can write all this perfect square, the square here as x squared minus 12x. Because of this, I guess I have to double it. Now, I have an example for you. Okay, so now look at it. We just solved x minus 6 all squared minus 36, and then we got that. Now, they say we should show that x squared minus 12x minus 1, okay, equal to x minus 6 minus 37. So instead of going all over again, okay, I'm going to use what I solved here, okay, to prove this here. Yeah, okay. So x squared minus 12x minus 1 equals x minus 6 all squared minus 37. Okay. Now, this is 36 here. So if I want to get minus 37, I subtracted minus 1 from both sides. So if I subtract minus 1 from both sides, I get x squared minus 12x minus 1, which will give me x minus 6 all squared minus 36 minus 1. So now I have x squared minus 12x minus 1 will be equal to x minus 6 minus 37. So I've solved it. Okay. These things, you can't go wrong. Especially if they give you this side of the equation, it's easy to start from x minus 6. Okay, deduce the perfect square, and then you start manipulating by looking at the numbers they have attached. Because they could have attached 43. So I could use this here, okay, see what I need to do to 36 to get 43. So I need to minus 7. So I'll minus 7 here as well to get me to the answer that I want. Okay, that's why I'm calling this part manipulations. Okay, and I couldn't have just done it without teaching you completing the squares, because even though it's not a perfect square, we still have shown that this can be written as this. So assuming I'm proving something, or I'm supposed to solve some dodgy equation, and I get here, I could substitute. If maybe I got this, I could find a way of completing the squares, manipulate it, assuming I got this, and then insert this. Because if there's a minus 12 and there's a minus 1 somewhere, I can get rid of that. Okay, a plus 12 and plus 1 in the equation, I can get rid of that. And then all I have will be x. And then I can continue from there. Because I still need to simplify. It's like sets. You can rationalize the numerator and the denominator. Okay. Now let's look at another one. So I have x minus 2 all squared. Okay, so if I break this down, I have x plus 2, another x plus 2. So now, if you multiply through, which you should be able to be doing now by yourself, x plus 2 all squared should be equal to x squared plus 4x plus 4. So I'm going to subtract this 4 from both sides. So I have x plus 2 all squared minus 4 equals x squared plus 4x. Now, because this is plus, if I double 2, I have x squared plus 4x. Okay, so we are seeing a pattern here. Okay. Now, furthermore, prove that x squared, x plus 2 all squared minus 1 will be equal to x squared plus 4x plus 3. So from this equation, what can I do? They've added 3 to this side. I have minus 1 here. So if I add 3 to both sides, okay, then I have x squared plus 4x plus 3, which will give me x plus 2 all squared minus 4 plus 3. Okay, because I want to end up here. So now I have x squared plus 4x plus 3 minus 4 plus 3 is what? Minus 1. So I've proved that x plus 2 all squared minus 1 is equal to x squared plus 4x plus 3. So I've arrived there. So just by starting with x plus 2 all squared, completing the squares to become this, okay, very soon you need to learn how to move from here to there, because this is 2, so the other side will be after you've expanded to get this, you know that you have x squared plus 4x plus 4. But assuming you can have this, so it's x squared plus 4x because of these 2. So I double that. And then minus 4 because there'll be a 4 here, so there'll be a minus 4 here. And then I've completed my square. So I can use that with anything they give me, okay, and then use that to prove, because this is gets a little. But what I'm saying is, assuming you are doing higher maths, because of this x plus 2 all squared, I can complete the square, manipulate my equation to look like this, assuming I got here, to look, and I can't use the quadratic equation to look like this. So it plays, for instance, if I have x plus 2 all squared, x plus 2 in the denominator of an equation, I can get this, okay, and the minus 1 in the numerator or the denominator. In place of this, in place of this, I can substitute that and then cancel all this off. Do you get what I mean? Yeah. So look at the equation given. So this is what we were asked to prove. So you look at the equation given, or you look at what you are working at, and then work towards your final answer. Okay. Thank you very much for joining me in today's video, and I'll see you in the next.